Hi again. So today I got an email that asked for questions about the last page in your packet with the exponents. And so I'm going to work through a couple of examples. I was asked specifically about 14, 16, 18, 20, and 24. So I want to take a minute. I'm going to work through two examples. 14, 16, 18, and 20 are very similar. And the other half, the odd problems, are just like it. So I pulled number 13 to put on this screen. And I'm going to go through and show you how I would approach this. So this entire problem is multiplication, all of it. You're not doing anything other than multiplying. So I'm going to take it and I'm going to reorder all of the things we're multiplying so that the numbers are side by side. And then the x's, there's only the x to the third. And then I'm going to put the u to the third and the u. And then the v to the fifth and the v to the third. That way, when I have them all side by side, you've got your numbers next to each other. You've got x by itself. You've got u's grouped together. And you've got v's grouped together. And then we just have to go through and we have to multiply each of these. So multiplying these three numbers together, that would be 7 times 8 is 56, times 10 is 560, and of course you could use a calculator there. There's nothing to combine the x to the third with, so it's just x to the third. These two combine, the u to the third, and it's really u to the first. And I'm going to add the two exponents. I'm going to add the 3 and the 1 for a total of u to the fourth. And then I'm going to do the same thing here. I'm going to add the 5 and the 3 together because I have 5 v's plus 3 more. So I have a total of v to the 8th. There's nothing else that can be combined. So to make it in simplest form, I would just remove those multiplication symbols, and you guys could go from that step to this step. I'm just emphasizing that we are multiplying everything. That's how all those problems are going to work. So you want to go through on 14, 16, 18, and 20, and you want to multiply the numbers. Then you want to find all of the like bases like I did here, the x's, and add their exponents, the u's, the v's, the y's. That's what you want to do with each one of those problems, is combine basically your like bases. So then the other question was about 24. And 24 looks similar to 21. So really what's happening here is I am taking what's inside the parentheses and I'm squaring it. So I could take this and I could rewrite it like 2x squared times 2x squared. It then becomes exactly like the problem above. I can do the 2 times the 2 times the x squared times the x squared. So I'm going to go ahead and I'm going to multiply these letters together, and then I'm going to multiply, those numbers together, and then I'm going to multiply my x's together. So I'm going to get 4x, and I'm going to add the 2's, x to the fourth. The other way to approach this is a little bit more sophisticated, and it would be, so this would be like a separate example. So let's say it was 3x to the third, and you were squaring it. Essentially, inside the parentheses, you've got the 3 and you've got the x to the third, and you're squaring it. Each of these things has to get squared. So it's like saying you have 3 squared times x to the third squared. Well, 3 squared is easy enough. That's just 9. And x to the third, there was that property that says really all we need to do is multiply those two exponents, so it would become x to the sixth. That's another way of approaching it, but certainly this method right here would work for any of the problems that you have, 22, 24, 26. They all would work that way. Otherwise, I would say maybe this is a little bit more sophisticated, and if you understand that, that's great. It's definitely something you're going to be looking at as you move forward into algebra class. All right, so I hope that helps. I'm going to go ahead and post this online.